Okay. Mm, saved. I don't know what's happening. My machine is now doing like snail tonight. Please.
Machine, don't do like snail, oh, please, oh.
Okay. All right. I believe we are here. We are here. We are here. Good evening, everyone. Good evening, everybody.
Good evening.
Oh, probably some person might not be
Evening.
in the evening. No, I don't know. I welcome everybody. Okay. Um. So all right. So good to see everyone today again, and as we continue our learning journey, it has not been easy, but we believe it will be easy. With consistency, everything will become easy. It's just time. So we are starting now. Others will join us. I believe we have a handful number of persons already. So yeah, Mr. Jude, you're welcome. So let's have a recap of what we had the other time. Let's have a recap. Our previous class, we talked about shell permissions, where we discussed file permissions, and where we discussed the type of the permission model available, or the type of way of applying permissions to files. We talked about the octal notation method and the symbolic notation method. So in that aspect too, we are able to break down how to identify different permission for files and directory when we list them. So we're able to see how each of the permission applies. Then we also talked about, okay, why am I even talking? I'm supposed to be asking us and we should be replying. Probably we should do that. Okay, let me start with, I'm going to call so that it will be organized. I'm going to call name. So let me call let me call Abisola. Abisola, yeah, please explain to us what you understand by file permission, and just everything you know that you can say within 2 minutes. Hello. Wow, she's not available. Okay, let me go to Mr. Sheriff. Mr. Sheriff, can you help us with anything? This is just to show that at least something was passed to us and we're able to grab something. And at the
Okay.
long run, we are giving it back based on how we understood.
Can you hear me?
Okay, I can hear you.
All right. I would say you may want to be very specific in question asking so that we don't waste time. You may like want to ask us things and let us give answers. I sort of eating, but I can try.
Okay. I like that aspect of being specific to manage time. Okay. Okay. What can you say about octal notation method for applying permissions to files?
Okay. Um, for octal notation, it involves working with three digits in particular, and those digits individually have about, I think, I would say three major like sections to them. Okay, you can say four, but the last one is zero. So there are the each one can only be up to seven. That is, they start from 0 to 7, which makes them 8. That is why it's called octal notation. So, so you have a CH mode and 652 or something like that. It means the six will be representing here. Meaning the six is here, four, and then two. I'm
Ready?
hearing myself in a lot of places.
Matak.
Hello, can you
Okay.
still hear me?
Yes, I can.
Okay. So it means the six can be split into two like categories. So I think so the categories I was supposed to talk about them before. So we have four sections of them like that. We have four for read. We have two for write. We have one for execute, and then zero for, I think that means nothing or something. I don't know. I think
All
that
right.
means no permission.
Okay.
So say when we have now we have 652 CHMO 652, and then if I we are trying to like give permission, we are trying to assign users permission to. So it means the six can be split into two, which is four and two. It
All
means we
right. I
only
think you
give
have done justice enough so that we can
up.
save time. Thank you so much for the explanation. Yes, you touched like some of the vital points as far as octa notation method of assigning permission is concerned. So thank you so much. I might not actually ask too much question again, but I just want to ask one more question. So just like you said, let me recap every other thing, everything you said. Just like do like a review for what we learned the other time. We talked about the method of applying permission to files, and we spoke about, okay, we spoke about the octal notation method, and then we talked about the second one, which is symbolic notation method. So basically, there are just two methods whereby you can apply permissions to files, which is octal notation and then symbolic notation. Okay, so in that aspect, the octal notation method involve the use of um, numbers that ranges from that range from 0 to 7. And when you count from 0 to 7, it forms an 8. And that is the reason why they call it octal notation. So going forward, we also talked about how permissions are being applied to files or directory. Now, when we are being specific about octal notation method, we talked about that it involves the use of numbers, and it is basically the use of three digits which are being applied to a particular file. For example, if we have if we should have for example, if I should create a file, okay, if I should create a file called hello, and I check the properties of this file using this list ls with this flag. Okay, now I checked I actually listed all the files in this directory. Okay, that's what this thing did, and it listed all the files and both directories there. As we said, that blue is for directory. Now going forth, this was the file I just created. Okay, and I we talked about how to identify properties of files. So talking that it says saying that it starts from the left hand side. And also I could remember the other time that we thought about that the permission pattern starts from left to right, from left to right. Okay, so in that aspect, in that way, you are able to see from this definition here, from this symbol, you are able to see the first um line here talks about the type of the file. Is it a directory or is it a regular file? Okay, so going forth, we now have the different permissions or access or privileges that this particular file that we are talking about it has. Okay, so now I was being specific about this file that I created. I'm going somewhere. Hello, and this is the file. So with being a dash, like our previous lesson where it said when it is a dash, it talks about that it is a regular file. And then going forth, we have triplets that are being formed. One, two, three, another triplet, another triplet. And the other time again, in terms of file permission, okay, there are three set of persons in which permission is applied to: the user, the group members, and everyone else. So when I'm talking about triplets here, we have a triplet, another triplet, and another triplet. So that triplet, it forms the three persons in which permission, access, or privileges can be given to. So, and I said it starts from the left to right. The first person at the left, starting from the left, is always the user or the owner, and then followed by the group, then followed by others or everyone else. So now in that aspect, three persons permission can be applied to them. Also, going forth, there are three sets of permissions that can be applied to that can be applied to a file or a directory, of which we were talking about. So which and this permission is either read, write, or execute. Okay, so this is just like a review of what we learned the other time. Let me open up um, something so that it can break down every explanation. So now we are actually talking about the octal notation. We are still going somewhere. Okay, so this is it here. So three set of person permission can be applied to the user, the group, and others. And there are three permissions that can be applicable to these three persons: read, write, execute. And that's why you can see they are being symbolized with RWX. Okay, so two ways of applying permission to files or directory: octal notation or symbolic notation. Now, the octal notation is what we are talking about, whereby it involves the use of 3 digits in order to apply permission. So now, when we are applying permission using the octal mode, since it is 3 digits, the 3 digits also applies to the three set of persons that permission can be given to, which is the user, the group, and others. So if we say we do chmod 600, okay, so to a particular file, this is saying that we are applying we are applying 600 to this file, and this 600 indicates 6 for the owner, 0 for the group member, and this other 0 for everyone else. So that is just basically how octal notation works. And just like Mr. Sheriff said, for every of the permission, when we are using octal notation or number system, they have each of the numbers there are numbers that have different meanings according to how permissions is being applied. And octal notation from 0 to 7 forming 8. So, but the basic number that forms the permission for read, write, and execute is 4, 2, 1, and 0. So 4 for read only, 2 for write only, 1 for execute only permission, and then 0 for no permission. If we add all of these together, we are going to form 8 bits, okay, making it to be octal. Now, for the symbolic system, in the symbolic system, it involves the use of symbols which they are being concatenated together or joined together in order to um, form permissions. Okay, so just like we have it here, I believe there's no need to just dive into all of this again. We have shared materials and we have broken down the basic concept needed. Let's practicalize some things in order to make them more explicit and to make it more understandable for us. So I have I have some practical question here. Although these are the things that we'll meet as far as this ALX is concerned. So can everybody hear me? Hello?
Yeah.
Okay. Is there any hello?
Yes.
Okay, you can continue. So let us look at something. Let's say we have this question comes. How do we execute this question? Okay, let us focus on something tonight. Let's focus on writing the script. Okay. Um, excuse me. So now, okay. Now, how do we write a script in shell? In shell. Now, in writing script in shell, there is a simple how will I say it? There is a standard notation, or is it notation I'll call it? There is a standard command that must be present in order to make a file, uh, to justify a file that it is a script. Okay. So, and that command is called, like they call it the shebang command. The shebang command. So the shebang command is what actually um, makes a file a script, and at the same time such that when you turn the file to an executable, that is to something that you can run, to something that you can run and it will execute a command, or it will perform a command. It is when this shebang command is available. It is when it is there. Okay, now so what is this shebang? It is just this thing that we have been seeing all this while. And sorry. So now in our upcoming project that we're going to see, we will always they will tell us that we should create a script that performs this, that performs that does this and that. It is the presence of this the presence of this code, of this command at the top most of our file. The presence of it, anything that goes in, like probably we are using the regular when we start using the regular Linux command like ls echo cat, um anything we want to talk about, they will now become valid as long as this man is at the top, is there. For example, if we should look at our code when we are doing the Git project, we could see that at the inclusion of this man here, when we open our file with when we open our file with vi, we could see that when we did echo ALX, echo ALX cool, we could see that this portion, the echo had is a particular color code, and then this file itself has particular color code. It is true, it is because of what? The inclusion of this command, this bin bash. So it is just like, I don't know what to call it, but it's just like the activator of making script executable. Okay, so now to create a script, all we just have to do is include this at the topmost level of our file and then start writing scripts. Let me practicalize that. For example, if I should do this hello file now, I want to make it an executable. I can do vi hello and I can include, sorry, I need to use another text editor. This vi is not okay. Now if I write echo, this man, if I should save, automatically this man is ready to be is already a script that can be executed. Okay, and what will this man do? This man is going to do, okay, can I ask a question? What will this, if I execute this file according to this code that is written here, let's just tax our brain. I don't want to say what will happen. Let somebody try to think what will happen if I should execute this man, like I add executable permission to it now and I run it. What will be the output on the screen? Anybody can just echo the answer.
I am now a script.
Okay.
Of course. So now I believe we can get the we are getting the concept of how this thing work. So looking at it, if we should turn this man to an executable and then run it, it will provide this action according to this command here. Okay, so in fact, okay, let's now the next step is let's make this man an executable. So okay, let me ask a question. How do I make this hello an executable now? Another person should echo. How do I make it an executable?
You give it, you give the like the user. I don't know who the user is going to be now. If it is going to be the main user, you give the you make the file an executable by, I don't know. Depends on which notation you are using. If it is octal, that will be one.
Okay.
Yes.
Okay, I
So
like that. I like from where you started, like it depends on
Yeah.
who we want to add the executable permission to. So first thing, like like we can try to see a list of the groups or members available. So for this file hello, we can see the permission available on the file. So we can see that the user have read and write permission, the group have read and write permission, but the others have read only permission. So let's add. So now another question is coming. We want to add executive permission to the user alone, to the user alone using symbolic method. How do we do it?
Sorry, Bamidele, I missed that part. Oh. Please, can you?
Of the part did you miss? What we want to do is we want to turn this file hello to an executable. How do we do it?
You could say CHMOD U plus X.
CHMOD. Whatever you say is what we are going to do. Okay, U plus X.
Oh,
No, 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 it's fine. There's no
okay.
issue.
Yeah, but yeah, what I'm just trying to say is, of course, you can add the executable parameter
Okay,
on the user himself because the user has the read and write already. So U plus
okay,
X will allow us on the user to add the executable.
okay. Yeah, exactly. You're right. So if we should run this now, the hello file will become an executable. And let's see. So let's list, long list, and selectively the hello file alone. And yes, exactly. So by running this command, we added the execute permission for the user for the on the hello file. We added execute permission for the user on the hello file. So now to run this now, we can run this script. Now basically running script in Linux is just dots and forward slash the script that we want to run, just like this. So dot forward slash the script. So if we should run this, we can see now that it has actually become a script and it has it has performed the action which is inside the script. So scripts are actually coded commands in a file such that when we run them, they perform their action. So as simple as that. Okay, now I believe now what have we learned so far now? This is just a crash course that is leading us to so that we can be able to answer some questions that are kind of technical here. And that's the essence of what I am doing. So what have we learned so far? We quickly learned how to create a script. Okay. So how to create a script and at the same time how to turn the script to become an executable, to make the script an executable, and then how to run it. So now basically to create a script, we have the file that we want to include the script command inside. Then after the file, what we add the commands, but we are already explained to us that there is always there is a necessary command or symbol that must be at the topmost level of our code or file or inside the file. It must be the first thing that must be there in order to turn whatever command that is inside the file to turn it into script. And that is what we call the shebang, which is this being bash here. Hash exclamation forward slash bin bash. Okay, so having this man here, whatever Linux command that comes underneath like this, they become executable. They can perform the action. So you remember when we are creating this, everything was like white. So now while I have turned it into a script and I open it back, it has become what? A command, and it has distinguished itself that this man is a Linux command which will perform this. All right. So now moving forward, let us see this. Let us go to before that. Let's go to our previous where we stopped. We actually we gave us like an assignment. Is it assignment and the evaluation we had the other time? Let's do all the tasks there. Let's practicalize them. Okay. So now for the first one, no, he said, let me copy it out. So he said, how do I set full access rights? Okay, full access right or permission. That's what it means to both the user, the group, and others of a particular network using symbolic notation. I believe this is just as simple as that. So, symbolic notation, we remember symbolic notation. When we are dealing with symbolic notation, the participants, we have the user in short form U, the group G, and others, which is O. So, altogether UGO, or we can call them A. It works the same way for the participants. So now, it is now telling us that what we need to set full access rights to both the user group and others for a particular network. So that is telling us that now the access rights that are possible, we've already said this the other time, the read, write, and execute. Okay. So how do we make it using symbolic notation? Anybody? Let's add it. We want to add it to a file called full access. So ls full access. How do we do it? We have just 10 minutes to round off this CHMOD and go to CH1 and CH group. Okay.
No, is it octal or symbolically?
Symbolic.
Okay, that will CH mode.
Mm-hmm.
That will UGVO plus. Don't know anyone works whether it is plus or RWX.
Okay. Okay. Clause works and also
It actually
equals
works.
to works. All right. Yes.
So
Okay.
full access.
The file name. Exactly. So for list, long list, we can see full access and it has all of the permissions. Okay. I think I won't ask the quiz. I won't ask someone to tell us. We'll just practicalize the answers that we have. Okay. So the next one, okay. Okay, this is it here. So how do I remove read, write, read and write permission from the user and group members of a network using symbolic notation. And we have this answer here to remove the read and write permission. Okay, I'm coming. There's a tricky question that is coming, and everybody will have to think. So, how do I remove read and write permission from the user, from the owner and group members of a network? So, let's say we are using the same file, full access. So, we want to remove read and write permission from full access for the user and group. Okay, according to this question. Okay, so what we have was chmod ug equals minus read write for full access. Now, if we should check full access, so that means that that answer was was wrong. This was the answer. I want everyone to be here. Are we together? This was the answer. That is, it removed the read and write permission from the user, from the owner and the group member. Okay, read and write from owner and group member. That means it is just to remove the read and write permission, and if there are existing permission there, should not touch them. So now, when we run the code, what we have here as before was we had the full access had read, write, and executable for every of the members, both for the user, for the group, and the others. Now, when we run this code, UG for user and the group equals to minus, it removed it removed even the previously existing permission that the file full access had from the user and from the group. That is why these triplets here are what? Are empty. So automatically, this equal to is the implication that happened there. Are we together?
Yes, we are.
Yeah, you said it yesterday that the equal to overrides any other permission that is there before. So for us to
Exactly.
be able to get that, there's no need for the equal to. We just put the
Equals
sign,
to.
either positive or negative. That's all.
So we are going to restore it back to the previous stage. So let's make it using the octal mode. The 777 will give every of the file full access. Yes, full permission. Okay. So when we do list full access, we are back. So now UG minus remove read write from full access. Remove the read write permission from the user and the group from the full access file. I didn't spell it well. Okay. So let's see. And yes, we are correct. So read and write permission has been removed. So that automatically this is the right code. So now another taxing question. Now let's go back to the previous one. Did everybody get it? I believe so. How can we get this value using the octal mode? How can we get it using the octal mode? We know that the octal mode, there is no option for us to set specific permission excluding the other person because it must always be 3 digits. But I think I read the article. I think it can be more than, it can be 2 digits, it can be 1 digit. We practicalize that. I've not practicalized it. But how can we make this happen too? How can we use octal mode to get this result? This result.
Okay.
Meanwhile, what we have already is, what we are having right now is this. So using octal mode, we need to have this. How can we get it?
It'll be 117 CHMOD.
Almost 117 full
Okay,
access.
okay, let's see. Perfect. Correct. Now there's something I want us to try now. Let's assume we want to use single or just double, not triple this time around. Let's see what will be the result. And like I said, I want to restore it back to full access, full permission. So now let us assume we want to specify double now, just for the user and the group. Let's see. This is on me. So that would be 1 1 full access. I don't know if it's an error that is coming. It worked, but let's see the result. So now it didn't work. Instead, it's okay. Now, can anybody check what happened here? It
Yeah,
happened from right to left instead of left to right.
I think we can achieve what we want, but then you would have to consider the what is it called first? The this last person, the orders, and then the group before the user. Can
Yes.
we try and use a single number and see what happens? Let's see, it will be falling under order. Yeah.
Okay, let me restore it back to the previous. So, so if we use a single number,
Oh,
like,
could you please clear your screen?
okay, so how are we gonna do it? Using a single number, just one on full access. I'm pretty sure it will be on the others. Okay, exactly. So in this aspect, what you want to say? You want to say something?
Okay, I was going to say if you're going to be using less than two numbers, it means we want to be like we'll be giving the user no access.
Yes. If we are using two, if we are using less than two, you mean
If you are using less than three, because
less than three?
it gave um, the group and then holders access, but it didn't give any access to the user.
Okay. Any other person with observation, if it is possible we achieve this? Is there a possibility?
What are we trying to achieve again? I thought.
Yeah, to set the some permissions to the user without touching.
Overwriting. Yes. Using Octal.
Uh, yeah, of course, this requires some thinking, I think.
Okay. Let's save that. Okay.
I think that instead of just giving one number or two numbers, remember, if you can remember, we said zero means no permission. Instead of just leaving the place blank, why can't you just put zero? So it won't confuse the system. So you can actually understand the kind of instruction we are giving it. Let's say you want to give
This we are using.
permission to only what is it group. So we can do 010. Do you understand? So only the group is getting the what
Actually,
is it?
if we should do 010, we are back to
Yeah.
the we are back to the
Getting
standard
three digits.
3 digits, and it will actually execute it like user, group, and others. So it will apply it to the three of them without even excluding anybody. So
Okay. What was the question?
so what we are trying to achieve, actually, we are just trying to achieve, we are cross playing around the terminal. How we can add just uh how we can add, where is the question? Sorry.
Adding a
How we
permission.
can remove read and write permission. Okay. How we can remove this read and write permission from just the user and the group without touching others. So it was possible with symbolic method. So we are trying to see if we can achieve it using octal. But I think, see, octal is always demanding three
Three
digits.
numbers. That's it. Yes. Three
So,
digits. Yes.
but I'm thinking that there's a possibility, but let's save that for later. Let's go to this. Um, there's a tax here. Okay, not this. Okay, can we do this? This is pretty simple. Write a script that sets the permission to the file hello. So we have to create a file hello as follows. The owner should have no permission at all. The group too should have no permission at all. Others users should have all the permission. On and the script, this is it here, is technical. The script is the one that will perform the action on this man. It's not that we are actually applying these permissions to this man, but instead we are creating a script such that when we run the script, it will apply all this permission on this man. So technically, the chmod command that will make all of this permission possible is to be inside the script. And then when we run the script, it will effect itself on this man. Did we get it?
Yes. Yes. Yes.
So how is it possible? Let me copy this. Let's break it down. I got it. Let's say this is it here. Oh, so we need a script. So we need a script. Let's call it script one. And then the change mode permission So this is basically what we are going to do. So we need a script that we have this, that will have the chmod command that will do all this permission inside this script, such that when we run it, now it will do the permission on the hello file, so that when we run it, this hello file will be transformed. So now let's do that. Firstly, let me clear the screen. Let me remove what is not necessary here. So firstly, let's create the file hello. So we have the file hello. So now let's create the script that will what? That will perform the action, just like we said. Sorry. So we have the hello file already. Now let's create the script. Sorry. I want to remove this script. There's an existing script there before. Okay, so let us create the script that will perform the action. I'm calling it script. Now we need to put the change mode command that will perform the permissions that we want to add on hello. Okay, so nano script. In fact, can we talk about how we are going to write the script? What are we going to do? How is it possible? How are we going to do it?
So we first put the
The shebang command. What's the shebang command? How are we writing it?
ask ask
As a okay,
information mark
CNC.
bin slash back
Exclamation mark. What slash?
slash bin slash back.
Okay. So now, don't talk again. Let another person
That's
talk.
the mic.
Okay.
Hello,
What are we
Mike.
going to do? Yes,
Okay,
I can.
Hello.
you can
I
type
can hear
CH
you.
mode. Okay, is
Okay.
it okay?
Okay. I wanted to find out if there is a space between the exclamation mark and the slash before the bin. Yeah.
There's actually
Not
no
necessarily.
space.
Okay.
Yes.
So hello,
Okay. What next?
CH mode 007, then the file name hello.
James Bond.
It is 007.
You know,
It is not
007.
700.
Okay. So, so this means no permission for no permission for the user,
Using HANA.
no permission for the group, full permission or access right to others. And this should be done on the hello file. This is just the interpretation. So the next thing to do is to save. The next thing is to save. And yes, let's check the hello file. Let's see. Now basically excuse me, basically the hello file is still the way it is. Let us view what is inside the script. Okay, cat script. Our command is inside. So now, how do we now make the action possible? Because we need to make the action possible such that when we view the properties of hello file, it should have this permission, this property that we have set here. So let me view the property of the LO file. This is it here. This is the current property of the LO file. So, and we said we want user to have nothing, no permission, group to have no permission, and others should have full permission. Now, the function is to make sure that this script is the means to which this man will happen. So how do we do it? What is the next step from here now in order to do the task?
I think we need to make the hello file. Um, okay. I don't know. We can make it an executable, can we? Should please.
You mean the LO file?
Yeah.
Yes, we can make the LO file executable, but not applying the action directly on the LO file.
Okay. As long
Instead, it should
as
be through the script file.
okay, as long as it is the script file we are running, it doesn't matter whether hello is executable or not.
Yes, it's the LO file we eventually, yes, have, it might eventually have executable permission after, probably after we run the script file. But what the goal right now is that we should make sure that this permission applies to the LO file, not directly resetting it on the LO file, but it should be through this script when we run this script.
Okay. Then we have to do the same CHMOD thing for hello on the normal level on this what is it called? In the shell itself. I don't know if
No,
I'm right.
Okay, I think we
no.
will open the script file. Hello, we will open the
I'm.
script file and
Mm-hmm.
then we'll initiate the command and change mode command on the hello file inside the script file.
Okay, let's get it. Let's just get it right. Remember, we've already written the command that will initiate this property on LO file. We've written it inside the script file already. So now the only thing that is needed is how are we going to activate this command on the LO file without touching the LO file by ourselves on the terminal. But instead, it should be possible such that it is when we run this script. So now the goal is like, how can we run this script? How can we make this script? How can we turn it to something that if we run it, it will perform these actions?
Okay, okay. I think I get this now. I think we need to make the script itself an executable file like that. Yeah.
Okay, for now, I probably another person should give idea. That is one from you, Mr. Sheriff. Another person, I think it's only three persons that are talking. No, how many persons do we have online?
I think we should try to run the script first. Let's see. After making it executable, then we should try and run it by using the command the dot and slash
So how do we do
command
it now? Okay,
dot slash.
walk us through. How do we do it? What is the next step right now? What do we do?
The next step is to make the script file executable.
So what do we do?
Okay, so let's check. Okay, so sorry, let's check. Let's list what is inside the script. I want to check maybe it has. Okay, it doesn't have an executable what is it called permission. So
Yes,
we
this is the
give the
property of the
file.
script.
Yeah, so we give it an executable permission first.
Okay, so that would be, what am I typing? Okay, so what do we do? You are the one controlling me now.
Ah,
What do we do? No, no, yes,
that's
yes.
what it's what 777 if I'm right.
Okay, you want us to use 777 on the script?
Yes.
Okay,
Yeah, enter.
so that means automatically this script has become executable by becoming green. So what is now the next step to do? So now
So the
let's
next
Let me clear the screen first. Let me list the properties of the hello file and then list property of the script file. So we want to make sure that this hello file, it has, this is the goal. This is the goal. The goal is, at the long run, the owner, the properties of the hello file, the owner should have no permission, the group should have no permission, but others should have all the permission. So what we are looking at is 007, just like we have. So
Oh, yeah,
dash
yeah,
dash
yeah.
dash 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 dash, then read write execute. So what do we do now? You've already walked us through that because we already have the code inside of the script file. So we want to execute this script file so that the action can be performed on the hello. And you've walked us through that we should turn the script
Okay, so
file to an executable.
okay,
So
so
what is now the next step?
you do dot slash
Okay, okay,
script.
all right. So
Yes.
let's see if it has been applied to the hello file. And yes, it's correct. It happened.
Okay.
Can we see?
I
So
tried.
basically, this has worked, and this is the goal. We indirectly applied an actions on a separate file without writing the command to the file itself, without even touching the file. Instead, we use a script as a means to apply the action on the file hello. So that's just the basic picture here. This script now, it has the command such that it will look through. Now let me cut script. Breaking this down, we have this man here which will activate Linux commands. And now what we wrote here is that we want to change the mode of any file. Check inside this current directory and check for any file called hello, and then apply this permission. That's just the explanation. Check for any file with the name hello and apply this permission code on it. Because if we are very careful, if we have like 100 hello, it will apply the permission to it. Oh. It will give all the hello files inside of it, will give them this permission. In fact, we can do another thing. We can be powerful with the shell, with the Linux. This is where it is so powerful. We can create another script, touch script 2. And now we want to create 3 files. We want to create text files, 3 text files. So 1.txt, 2.txt, 3.txt. We are creating these text files. Now, this is the goal that we want to achieve. The goal is that we want to create a script that will turn all these text files into an executable file. Okay, that will give them execute permission. Okay, so but we don't want to do chmod. Probably we say chmod. Probably we say user plus. We are adding executable permission to the user for all, for 1.txt, for 2.txt, for 3.txt. We don't want to do this one. We don't want to do it this way. We don't even want to write it this way. We want to create like a script that will automatically transform any text file into an executable, that will automatically add execute permission to any text file. That is the goal. You can see how powerful this thing will be. That means if eventually we start creating um Eventually, we start creating text files inside this directory. As long as we keep running that script, it will what? Continuously turn them to executable. Now, I want to confess to us that something just dropped to my mind now, that I believe this is how the virus are being created, probably in Windows or probably anywhere. This is how antivirus are being created, such that there are some kind of files that have some kind of extensions which identify them identify them as virus. So now there will be a script that will be created that once you find any file with this kind of extension, delete them or quarantine them or give us an alert. I don't know if anybody is getting this. This is where we now need to be practical with how we can use every of these shell command. Imagine having a script that can perform a particular type of um type of action on multiples of files, as long as those files keep what? Existing. So we want to create a script that is going to turn any text file, that's going to add execute permission to any text file that exists in this directory. As long as they exist in this directory and as long as we run the script, it will always turn them to an execute. It will always add execute permission to them. Do we get the idea? So
Yep.
now, how do we achieve this? I'm not going to give the answer. What we want to do is this script is going to turn every text file in this directory. It's going to turn them into an executable. Now, there's also something we call, let me give us an hint. Although this will be in the resources that will be given to us soon. There's something we call expansion in Linux. Expansion in Linux is like a way of, just like the word, I don't want this definition. Just like when we type a particular command, it expands it into every of every of the every of the target files that what that that fall under that category. Now, I like this. There are different type of expansion actually. We have variable substitution expansion according to how it is written here. Let me increase it. We have variable substitution expansion, we have command substitution expansion, we have arithmetic expansion, and then we have wildcard expansion. Now, this wildcard, he said it matches any sequence of character. That is, once we use this asterisk, any character that fall within the specified thing that we talk about, it will what? It will affect it. Now, in order to make this simple, let us do something. Let's say I create 5 files with the name 1 2 3 4 5. So touch one. Okay, touch one. Let me touch one dot. Okay, no, let me create this file. Touch file dot txt. Okay. JPG file 2.jpg file 3.jpg. Okay, this is what we have here. Now, let me list what the files we have. We have this file 2.jpg, file.jpg. All the files having JPG extension. Okay. Now, let me say I want to do something now. I want to delete every file that has JPG extension. This is it. This is the task I want to do. Okay, this is the focus. So my mission is to delete every file that has .jpg extension. Technically, in a normal way, what I can do is remove file. Firstly, I can say I want to list all the files. I can now say, okay, remove file.jpg and remove file2.jpg. And yes, if I run this, these two files will be removed and deleted. But I can make it, if what if I have up like 100 JPG files? Am I going to be typing them 1, 2, 3, 4, 5, 6, 7, 8? And this is where, as a programmer, as somebody who can automate anything, finding the best means to solve a problem is actually our task. So if we learn any tool, or if we learn any command or anything, our next target is to be thinking of how we can use it to solve problem in terms of when we have larger number. So simple thing I can always do is to use the remove command, and then this man here, this asterisk, is talking about, is saying that it should what, remove anything that what, that now, if I now say remove anything that has .jpg extension from this directory, everything that has that extension, it will automatically remove them. So it will save me time of typing file.jpg, file2.jpg. I don't have to do that. All I can do is remove every .jpg file. And if I do this, if I list file, you can see all the .jpg file is gone. Nothing is here. As powerful as this thing can be, it can be dangerous too, because Linux now, once you run a password, unless you specify that it should be interactive, if you just press enter, that is it, it's gone. If, for example, I make a mistake and I say remove every directory, if I should press enter, everything here, every directory that is here, it will what, it will delete them. It will delete them automatically, unless, okay, unless right now the only thing that it might give me like a prompt if this user, this directory that is here as my current user, being this current user does not have the permission to do that. But if it is being, if I am in the root directory, and I do all of, and I say something like this, it will what, it might delete all the directories here. So another illustration, let me create another file.mp3, file2 .mp3, file3 .mp3, file4 .mp3. So I'm creating them, sorry. So touch. So with the touch file, with touch command, it will create all of this. Now the next thing is I have created them. If I list them, you can see them. They are all here. So let's say I want to move. Let us say I want to move all mp3 files to music directory. So how can I achieve this? I want to move M, all music files, all mp3 files to the music directory. So basically, I can say I can say I'll do move file.mp3 file 2.mp3. Imagine me typing all of that. If I have like 100, it cannot save me time. So in that simple sense, I can use the wildcard, one of the wildcard syntax with the move, that is, you should move all mp3 extension, any file in this current space, this current directory that I am, it should move everything into music directory. So I can say /music directory. So when I run this, sorry, I think I don't need to use the / since I am inside. I can just put it like this. So when I run this, it will what? It will move it. Let's see. You can't see anything here again. But when I list the files of the music directory, can we see? So this Linux, whatever, this is just like the tip of the iceberg. We can use it to find, using this man as it is, we can use it to find anything that has to do with MP3 or anything that has to do with extension, or based on the parameter, we can use it to find it in this directory or use it to execute um, actions on it. So that is just like this white card that we are talking about here. Now let's go back to where we are. What we have here, we want to we want to create create a script that will remove any .txt file in this directory. Okay, it is going to, the mission is to remove any .txt file in this current directory. To create a script that will remove any .txt file in this current directory. So now, how do we do it? I'm not going to do it though. We have to be interactive. I've spoken enough.
Hello.
Okay, I don't want you to talk, Mr. Sheriff. I want another person to talk. Probably Mr. Jude. Probably Mr. Ramothamo.
Yeah,
Probably Annabelle. Probably Brandon. Abisola too will not speak because she has been interactive. So any other person aside Abisola Sheriff.
yeah. You might have to create a script using the Shiba command
Okay,
that will
so
actually.
let me give you an hint. We have a file already that is going to have the script, which is script 2. So
Mhm.
take the step now. What do I do?
Okay, with the assistance of the others, of course. You might want to open uh,
Okay,
the Nano, whatever editor you have,
all
script
right.
2. Yeah.
Okay, I'm inside.
Yeah. So once you are inside, you run the shebang, the hashtag exclamation / bimbash.
Okay, okay. So what do I do next?
Yeah. From here, now we can start writing the commands that will execute what we want to do. So, what is it that we want to do? We said we want to.
The script is going to remove. Okay, initially what I said initially while I was explaining was it's going to turn every txt file to executable, but let's change it now. It's going to remove any file that has txt extension
Okay.
from this current directory.
Okay. Yeah. So, that are we gonna run the RM,
Okay,
then space your asterisk
okay,
on dot, is
okay,
it dot txt?
okay. Now this is where it becomes tricky. It's going to be on the current directory.
Yes.
So we are working on the current directory. We are not it is not like we are applying it to a specific file, but we are working with directory this time around.
Okay, so we have to specify that on the current directory.
Yes. So how do we specify it? How do we reference current directory?
I might need some help while I think about that one.
Okay. Now let me do something. I want to give an hint. Let me exit this. We are coming back to this. You are still the one to walk us through finally. But let me give an hint. I'm coming. How do we print the current directory that we are? How do we know the current directory that we
Uh,
are in?
PWD.
PWD, right? Okay. So when we run PWD, it actually give us this, telling us the name of the current directory that we are, right?
Mhm.
But
Mm.
now let us be practical now. Let us do something. I want to move from this directory. I want to move into I want to move into music. How do we do that? I want to change from this directory Urban Tech. I want to move into music. How do I do that?
You run CD music,
CD
uh,
music. Okay.
CD forward slash music, is it?
Do I need? I don't need to, because if I say forward slash music, it is going to recognize it like the name of the directory I'm moving into is forward slash. Forward slash
Okay.
will apply if I have the plan to move into a directory inside this directory. So if I have
Okay.
plan to
Okay.
move into a
Okay.
directory
Okay.
inside a directory.
All right.
Okay.
All right.
So like this, it will take me into music. So I'm inside music now. Now, how do I go back? How do I go back to? Okay, now, okay.
Okay.
Let me make
All right.
directory. You are getting it, right? Let me make
Yeah,
a
somewhat.
directory. Let me make a directory called A. Okay. Now I want to move into a CDA, right?
Yes.
Good. How do I go back to music?
Uh, would we dot something?
CD dot
Huh?
CD
CD dot dot
CD
dot.
dot dot.
CD dot dot.
Yes.
It takes me to music, right? But now
Exactly.
let's try something. Let me go back to A.
Mhm.
If I do CD dot, what will happen? Just single dot. Can you see?
Single dot to take you back.
It will keep
Yeah.
me there.
Yeah.
Single dot will keep me. Single
Where you
dot
are.
indicates current. Take me to still be in the
Current
current.
working directory.
Yes.
Yeah.
Why CD dot dot means take me to the parent
Parent directory.
directory.
Okay.
I have given an int now. I'll be a
Yes.
int. I don't
Yes.
know.
Yes.
So
Yes. You
we
have.
can we should be able to solve the problem now, right?
Yeah. Hopefully.
Okay, so I'll go cd dot dot back to the parent directory, still to the parent directory, still.
Okay,
Okay,
Mike.
I
What if you are
okay.
okay? What if you are in a directory inside another directory, like three different paths away from root?
If I am, let's say I'm inside music. For music, I'm inside A. Let me make another directory. I am inside B. I'll make directory B, CDB. So now I am, look at where I am now. Look at the track. A, B, music. And look at it too. B is inside A is inside music, music is inside urban tech. So what is the mission? What do we want to do?
The mission is to remove all the Uh, or I'm not sure if you're asking towards the
No, not
original
you.
question.
Someone spoke about something that what if we are inside three directory away?
Okay.
Who spoke? I was not on the screen.
Yeah, it's Jude. So the question was, given where we are now, will the
Okay.
CD dot take us back to the parent directory, which in this case was music, or will it take us to
We
A, which is the parent of
if
B?
we okay, cd dot dot always take us to the parent directory. Cd dot dot will always take us to the parent directory. And for every parent, there can be
Oh, Michael.
grandparents, there can be great grand.
Yeah,
Yes.
yeah, that's the point I wanted to make. So, what this means is, A is the parent directory of B.
For
Music
B,
is the parent directory of A. You
for
understand?
A,
Why?
exactly.
Yes. Why Overset is the parent directory for? It's even the root directory for music. You understand? So, that's it. That's how it is. So it's just like
So
Overset is great parents, great grandparents, and stuff like that. So I don't know. Maybe you understand my explanation.
okay. So did you get it now, Jude?
Yes,
So
I get that quite well.
anytime I run cd dot dot, it will take me to the parent, the initial parent. If that one has another parent, if I run cd dot dot, it will take me to the parent there. If I run cd dot dot, it will take me to the parent. Now, somebody should be asking a question that do I have to do dot 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 dot? What if I want to move
Hello.
from B directly to Obamtech? Yes.
Okay, that is what I was going to say next. I think I've seen something like C as in C dash
So
dash
let's do that. If I let's move into
C
music
dash
back.
dash. Okay.
See the music. In fact, I can let me try something. I can move into B directly doing this.
Yeah, yeah.
Let's see. It worked. I'm saying from this man, take me into this man, but follow this road. Follow music road, follow A road, and then come to my final destination. Or we call it path, the technical name path. So from
Can
this
we do, can we
Please,
do
please,
something?
please clear the screen.
Can we do
yes,
CD slash music? I want to try.
when you do like this, you are moving forward.
Okay.
This is one thing that we need to understand. Whenever you are like this, you are moving forward. If you have to move backward, the dot dot
Yeah.
is the pointer. So this is like a take home. Whenever you want to move backward, the dot dot is the pointer to moving backward. So obviously, if I'm to go to Obamtech, all I have to do is cd dot dot forward slash Obamtech. So absolutely, it will take me to Obamtech. Oh, it didn't work. Oh,
Hello,
okay.
hello.
Yes,
I think this is where the CD dash dash comes in. Like hyphen
dash
hyphen.
dash.
Yes,
You mean hyphen hyphen?
yes.
Okay, let's see. Like this? I don't think so. Wow, I've learned something. I never thought of this. It worked.
Actually tried it in the shell. What is it called?
Okay.
So it worked.
So we can actually check the manual for CD. No
Yeah.
manual. Okay. Okay, something has been achieved. Okay, there is something I
I
wanted to do.
think also,
Mm-hmm.
I don't know. I think also CD, just writing CD will take us there.
Okay, let's see. Let me go back into music, into a. into B. Just CD. Let's see. Okay. Okay. There's something I want to test by my own self. CD forward slash. Okay, that didn't work. Oh, okay. CD dot forward slash. Then the name. Okay, that didn't work. Then you guys are actually right. Ordinary CD works. Okay. And then um and then CD dash dash works also. Okay. All right. So back to where we are running it, we are working on a script. We have been able to achieve something. Dot takes you, puts you in the current place. You are, it will put you at the current directory. Dot dot changes you to the parent directory. Ordinary CD takes you to the root directory. Is this point, I think it is being established now. Do we get it? So where we had before, so how do we continue from here, Mr. Ramo Samo?
Yeah, no, of course, from this point, we have to figure out how we make sure that only the text files or the txt files in the current directory
Current
will be
directory.
updated.
Yes.
Yeah, so I'm trying to wrap my mind around how to place
Okay, let me work it out.
mm,
To make that happen, all we just have to do is cd dot.
the current directory. Okay.
Let's see. It should work. I'm not even sure, but it should work. Are we together? So now let's save it. So if we should run the script, first the next thing to do is to what? Is to make the script an executable, right? So that's
Yes.
where we do
Dot.
change change mode. We have to change the mode. This is
Yeah.
script 2.
Mm-hmm.
So change mode script. Oh, sorry. Add execute permission to the user script 2. Okay. So script 2 is already an executable. So when we run script 2, let's see. I hope this does not blow the system up. Ah, it didn't work. Cannot remove CD. No such file or directory. Okay. What is
Hello,
the solution?
hello.
Mr. Sheriff, don't say anything. I already know what the solution is, but don't say anything. Another person should talk. Let me open the script file back. Our script is wrong. What should be, so our script is saying that it can, technically what it's saying now from the error, let me go back. What it's saying from the error is that remove cannot remove CD because it cannot find a directory or file with that name. And it cannot remove dot because dot is a directory. So something is not correct. Is not correct. We need to check. Our command is actually, we are telling rm command to remove everything called txt in that current directory. So basically, there should be a way to go around it. What do we
So
do?
can I ask? Sorry. Okay. Is the problem there with the cd dot, or it's with the command itself? Uh, because of the type of content we have in some of those directories.
Actually, what the prompt is saying is what this is what we have inside the script, right? The prompt is saying that it cannot remove CD and it cannot remove dots. And in fact, something is coming to my mind. Do you know that this prompt, the script already has removed all the text file itself? If I list the file now, we should see that the text file should be gone. The txt file should be gone. In the sense that what this can be saying is that it is seeing the txt files, the cd files, and the dots as separate entities.
Mm-hmm.
Let us check. Let's list file. Can you see it's gone? So basically, there is no need to specify current directory or not, because this is
We are
where
all
we are already in the current directory, and this dot already is working as the current directory as long as we run it on the
I was
script.
about to say that.
So I am already understanding
okay.
this. Okay,
Okay.
yes,
The dot where we run the script dot forward slash script two.
exactly.
Okay. All right. All right.
So it is
That
clear
is very
So
already.
interesting.
so what that means so what that means is that the script two was
Mm-hmm.
under the group directory, that's urban text, was already under the directory where we initiated the change, the command. So for example, let's say that we are under which other directory is this? Let's say desktop or document. I think that's the directory. I'm not right. I'm right. Let's say we created a directory. The directory desktop. How you guys hear me? And then
Okay,
uh, the script2 file is under that directory. I
it's
don't know if you get
inside
some of that.
desktop.
It's inside here. It's inside this desktop.
This one, okay, is inside here. Okay, okay.
So
So
let's
you
take
now
this
mean
directory.
okay? I've made the directory. Let me move script to there.
Okay. So yes, let's move to script2 desktop.
Okay. So
So what I'm trying, the question I'm trying to, what I'm trying to explain is,
mm-hmm.
okay. So we have, okay, so let's create a file dot text, the text, the word text, the text, with under
Inside where desktop.
inside, yes, inside desktop, yes, directory. Do you understand?
Right?
Yes.
I'm trying to use shortcut. Okay.
Mm.
I think I need to stop shortcut now and just follow the rule. I've not.
So see the desktop now.
It
Hmm.
would have worked if it was just a simple file function.
So that's list file. Okay, okay. You want to create it.
Okay. So we are inside the desktop and
Now,
we've created. Mm-hmm.
so let's see if that question of removing all the file that had .txt would apply here. Do you
So
understand?
we should go back to Obam Tech now
So
and
yes,
run the scripts. Is
yes,
that
let's
what you
run it.
meant? But
Yes,
that means the script is not inside Obam Tech anymore. You know, we have moved it into desktop. Should we move
that's
it
what I'm
back to
saying.
Obam
So
Tech?
no, let's
We should run the
let's
script like
change
this.
direct text. No, let's change directly to desktop. You know we have moved the script to desktop um, directory. So let's change
Okay.
directly to desktop and let's run that script. Let's see if it will work.
We should run the script now,
Yes, let's run it.
right?
Yes,
Okay.
just that script. Script
Okay.
two.
What before we run the script, what is the expected output that you are thinking? should
The
happen.
expected happen is that all this text, all this file with text um would be removed. That's the expected output because that was what the command we initiated inside script two, if I'm right
Okay.
earlier, that we used earlier.
Now, to be specific, the expected output is that you want all the txt file inside this desktop directory, current directory, to be removed. Is that the?
Yes, 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 yes.
Of course, it will, but
Yeah,
it will
yeah,
give
it
us
will work
that. It will
because
still.
we have one the dot there specified that in this current directory, and the script
Okay,
is in the desktop directory. So I think it will work.
let's run it. Can you see? That's the first error, and then list file. It worked.
Yeah,
It
the error
works.
is just because the error is because of the CD and the dot that we have in the script there.
Specified. Can you see? It worked.
Yes, yes.
But there is something that we should be able to achieve. Now let me move. Let me move the script too far back to the root. Am I correct? How do I do this? Will this work? Should I run it? I don't know if I'm correct though.
Let us try this.
To the root,
Yes. How do we do it? I'm on already.
I think there's no need for slash. Let's try the doctor first.
It worked.
Okay.
It worked. So it's here, right? Now let me enter the script too. Now, can we achieve something that it should remove every txt file inside the parent directory, not the current directory now. Now, what we explained before now is when we use this, it is seeing txt as a separate file, cd as a separate file, and then dot as a separate file. So that was the error initially. So automatically these ones are not needed. So we are saying that it should remove all txt file in that current directory if this is the case. But now, let's say we want to remove all txt file in the parent directory. So how do we do it?
Okay,
Now
can I
you know
talk now?
yes you can exactly.
All right. So for I think first we need to put something above the remove command. That will help us navigate to the parent directory. That will be cd dot dot.
Remove before the text it remove dot
No,
see
before rm at
how
all.
do we do it? You
Before
said
rm.
cd dot dot. Okay, then like this,
I think this should come down. The rm and then all those ones should come down. Yeah.
like this.
Yes.
Wow. Okay, this is logical, but let's see. So automatically you are saying from this script, run this script, change the directory to the parent directory, and remove all
Then
txt
delete the
file.
text files in that parent directory. Yeah.
Let's see. I believe everyone got the idea there, the logic there.
It makes sense.
Okay. Let's see what we have here. We have 2.txt. Let's create more. Touch 4.txt, 5.txt. Now let us move into desktop. We are listing file. We have all this text file there. Okay. So cd desktop. No. Cd dot first. ls. We have to move this script
Move
file.
script into desktop.
Yes. So move script to desktop so that it can perform the action. Now we can now say um ls. Okay, sorry. We can now change directory into desktop ls. Now let's run the script, right? So /script 2. Okay.
So,
Actually, it worked, but let's see. Let's see if it really worked. It worked. It worked actually. It
Okay.
worked. But now, do you know something that yeah, it's good to clap. Well done. Yeah, it's worked. But now there's something. I want to be realistic. By the time we start working with our project, this is what ALX will tell you. Let me come. I'm coming. Let me clear the screen. CD desktop ls nano script 2. How many line do we have here? How many line is this?
three lines. ALX will tell you 2 lines.
3 lines, right? ALS will tell you 2 lines. That is, whatever code you have to write should not be. It should be between shebang and the next line should execute your code. So how can we achieve that? Wait, we are not going to dive at that. Let everybody go and be thinking about that. Let's move to something else. But this is achievable. This has worked, right? It has actually worked. So trying to make sure that how can we achieve an instruction or a command in just 2 lines without 3 lines. That's it. So but we've been able to achieve this. This has worked. Good. Now let's move to something. There's something critical again that we want to check. Let's say let us create this script now. Let's create another script. Let me do cd dot. I want to remove the desktop directory. Don't need it again. Okay, so we have the script, we have the hello file. Now, this is another task to create a script that adds executable permission to only to only files in the subdirectories of the current directory. Glory. Is everybody together? Are we together? This is
Wow.
the mission. The mission is to create a script that adds executive permission to only files or to files, if the English is to files in the subdirectory, that is all the files in the subdirectories of the current directory. Don't touch any file in this current directory, but go to the subdirectory of the current directory. Is it clear? Is it not confusing? Hi.
It is clear. Achieving it is the problem now.
So let me do this. Okay, we don't want to waste time. This is what I'm gonna do. I'm gonna copy this out. We think about it by the side, but let's talk about a feature that is necessary at this point. Um, 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 what do I do? Okay, so search file. Right. So we have the tags that is inside there. Let us talk about something else. Let's talk about redirection. Okay. Where is this guy? Where is this guy? We are still coming to um we are still going to ch own. There is something about it, but it's simple. It is similar to CHMOD. That is why I don't want to really just go into it like instantly. It is similar. In fact, it is very simple, but we are coming to that. Let's talk about this very critical, because this is where the power of Linux start from. Now, we want to talk about shell input and output redirection. Shell input and output redirection. Obviously, as a computer, of course, when we want to define a computer, there are some terminologies if you are defining computer system that must be present in order to justify that what you are defining or what you define is a computer. So, and this terminology is broken down. It's just three terminology that must be present in your definition of a computer. That is input, process, output. Okay, so computer must be able to accept input. If it is truly a computer, it must be able to accept input, and after accepting the input, it must be able to process the input that it has received, and then it must be able to give corresponding output, of which according to what the instruction given to it by the user. So the same thing happens in shell input and output, where we talk about input output redirection. So from what we have here, we have output redirection. It said the output from a command normally intended for standard output can be easily diverted to a file. So now breaking down the concept first before we even talk about mm, 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 before 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 I start diving with that book. Firstly, we have the concept here. We have shell. The terminologies, we have input, we have output, and we have redirection. So shell normally is this environment that help us to do Linux command, and we can interact with the Linux OS. So the Linux OS run on the shell for us to be able to write Linux or Linux commands. That is settled. So now input is sending in data, all right? Then output is what? Sending out data according to the given input. Now redirection, just as we want to talk about redirection, is like if we send input, if you send input, there is a standard output that every input what will be produced. Okay, for example, when we talk about input devices, when we talk about the keyboard, we talk about the computer, we talk about input devices and output devices, right? So when we talk about examples of input devices, device that allows us to send data into the computer system, we have the keyboard, we have the mouse. Input devices, we have the light pen, you know, we have the scanner, as long as they allows us to collect input from the outside and send into the computer. Now, it is very, very evident that we understand that for every input device, they have their corresponding output device that they work with. For example, whenever you use a keyboard, it will send input into the computer. And for you to be able to access the input that you send you send through the keyboard, there must be an output device that works, that complements the keyboard as an input device. And that is what the screen, the monitor. The same thing applies to a scanner, that whenever you use a scanner to scan in document, image into the computer, there must be a channel that the scanner will follow, and then it must what? It must always display an output. And every output is always the screen. Whenever you input data via the any input device, there, in order to for us to be able to visualize it, the screen is always what? The output. So the standard input, standard output is always the screen. Standard input can be any form, but when we come to shell now, the standard input is all the commands that does input, that gives input. Okay, for example, when for example, command that gives input, if we talk about, okay, create a file, touch, we can do that. When we create a file, when we open the file, when we input data into the file, we are working like the standard input. We are doing input, we are inputting data. When we now do something like, when we run a command like cat a particular file, it what? It gives us output. And the output is according to what? The content into the file that is being concerned. And where do we see the output? The standard output is always the screen. I've been able to break down input, output, shell. I think that is understandable a bit. Now, redirection. From the word redirection, it means to change direction. Change direction. That's what even the basic word that is coming that I can explain. That is, instead of, if I have, okay, normally if I run a program, excuse me, if I should do, if we should do something like touch file, and we do di file, and then we wrote content, we write it inside this file. Now, to view the file, we can do cat file, and it will what? Without doubt, it will what? It will give us, it will display, let me make it file one. Okay, it will view the content of the file, name file one. Okay, right? And where is this? Where are the contents? Where are they going to be displayed? The content is displayed on the screen, right? Yes. Now, we can redirect the content from displaying onto the screen into another file. This is what this is what redirection is all about, whereby redirecting, changing direction of where of a command, just change the direction of command. So if it's an input command, change the direction to the specified direction that is being given. If it's an output command, change the direction. That is what input output redirection is all about. So because of the power of the Linux or the shell or Unix or OS, we can perform all of this operation. We can redirect. For example, you remember when we were doing the Git project, when we wanted to create a readme file, options, we can say use vi readme.md or echo message greater than. We can do that, but we have been doing echo message and then into file, but we don't even we are actually not observant of, we we are not observant of what has happened. You understand? So this man here, echo itself is a command that always that the function of the echo is that it always displays content to the screen. But we don't want echo to display the content on the screen that we are creating, but we want it to what? Send this content into file. And this is what we call input output redirection, because this man is an output command, outputting its command and outputting it into file. So I have talked randomly, I have talked about um, input and output redirection, what redirection means, the concept itself. This same way it applies to the same thing that we can do, like how can we do, we can say cats, we can feed in um okay, okay, now we can do this. No, let me don't use cat, I'm unsure about that command. We can say list file, okay, list the content of the directory file and send and perform long list L on this file at the same time. We'll perform this on the terminal. So I've been able to cover the concept of input to output redirection, and now let us look at this. He said the output from a command normally intended for standard output can be easily diverted to a file instead. That is, the output from a normal standard output command can be diverted into a file instead. And this is called output redirection. And we have the notation greater than sign. Okay. Whenever it's appended to any command, it what? It writes that output. Okay. Let's practicalize something. Let's say I want to list file in this current directory. Now this is desktop, this is downloads, music, and all these things inside. Now we don't want it to display on the screen. Don't forget, every command they have They fall under different category of what type of command they are. Probably they are standard output command, or probably they are standard input command, you know, just like they are. So ls, excuse me, is a standard output command such that when you apply it to a directory or to a file, it what? It displays the properties to the screen. So in that case and in that sense, if I should do ls, I have done ls, which we did here. It displayed all the files, it listed all the files inside this directory. Now I can redirect everything inside here, and I can tell it that I should not save it to the screen. Instead, save it inside a file called new file. So I can do ls save output, redirect the output, this man, redirect the output into new file. And look at, this is ls, make cat new file. And we see everything, and it has turned them into a file. So this output redirection is of two types. The normal output redirection, this one overwrites whatever content is inside the file that we are outputting to, or that we are redirecting to. Why? If it is greater than, like this one, it's, let me clear the screen. If it is like this one appends, it appends whatever we are redirecting into what? Into the file we are redirecting to. Let's say I want to now do, if I do, let me clear screen. I do ls new file. Sorry. If I should do cat new file, this is what we have. Now let me do echo. I am just a regular file, and I'm using this single output redirection. Now if I cat new file, all the previously existing content, they are gone, and they have been overwritten with this one. That is the function of this man here. So in that case, if I want to preserve these people here at the point, and I want to append a new file, since now I have actually overwritten all of this here with this man here. Let's say I want to preserve this man, and I want to add another line to it, but this man should still remain, should not be removed. That is when we use the double greater than sign, which appends a redirection. So I am just a regular file. You can turn me into anything. Now watch. So if I clear the screen, ls cat new file, and you see now it is on the what? The second line. So this has worked for, this is just the basic concept of how standard output redirection works. Now let us go to standard input redirection. Just like they said here, you can use to append. Now input redirection, just as the output of a command can be directed to a file, so the input of the command can be redirected from a file. So the output is to a file, and this one is from a file. That means I can do cat the content of new file. Can this work? So I am sending the content of this into cart. Okay, let's continue. I just tested that. I don't think that makes sense. Okay, the commands can normally take their input from the standard input, can have their input redirected from a file in this manner. Okay, let's see. For example, to count the number of lines in the file user generated above. Okay, so we can say word count. This man is short form for word count in a long list users, and it will count users and then display users. Okay, we can now say upon execution you will receive the following output. We can say word count long list and send the value of users, send the number of lines in users. We are sending it, okay, we are sending it into word count. Let me break it again. I think that one is not okay. What we are doing here is this man is like a processor, a processing machine that will always give output. But for it to produce output, it must receive an input. Okay. So for it must receive an input that it will work on and then what? Give output. So we are sending or inputting users, we are feeding it inside word count. So as we feed users into word count, it gives the output of how many lines is inside. I think this justifies. Let's say we have cat new file. No, I want to add another line to new file. So echo, you can choose to remove me if you like inside appending it into new file. So we can clear screen and cat new file. So now we have this one. Now this command word count L, if we run it ordinarily like this, of course this man is on a directory and now it is not performing any action because it is just trying to search for what? It's trying to search for words or files to count from and it cannot find anything. But if we should do word count new file, it is sending, look at what it displayed. It is giving us the output, the number of lines inside new file. It is giving us 3, and then it is giving us the file itself back. It is sending the number of lines inside new file, send it to the output screen, and also referencing or displaying the file that we dealt with. We can do something like, I just want you to give me the number of lines, but don't give me the file. That is where we say we are redirecting the input into this. When we do word count, long list, feeding it into, we are feeding new file. So it comes from right to left. We are feeding new file inside word count. And it gives us just the number of lines inside. Am I talking to people? Let me see. Hello.
Yeah, yeah.
Yeah, can hear you. I
So
was
I
going
think
to ask if we have anything.
if we are hello.
So I expected the word count to count all of the words we have in the new file, but it's counting the lines instead.
Yes, this is I specified line. This flag here. Let's check the
Okay.
manual for word count. Check it prints new line, it prints words, and it's byte count for each file. If we come down, this flag C, it prints the bytes count. This flag M, it prints the character count. Single character, like I am a new file. So from I to A to space and everything, all character that forms. Now you can see the flag L, it prints the every new line. It's every new line it prints. So every of the flag there. Now you can for word now you can see it prints the word count. So we can do that now if we want to count how many words are there. Q. If I say I'm feeding in, what is the flag for word? Imagine I didn't even grab take it. For word is W, okay? Flag W for words in order to see the number of words there. So word count flag give me the number of words of new file. That's 20. So cat new file. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Can we see it now? Now, while I'm doing all of this thing, I'm thinking deep because this can be very effective for writing a programming language, as in Bash. The programming language, when you use shell to write programming language, it's like you call it Bash script or Bash programming or shell programming, but it's mainly Bash because the being Bash, shebang, whatever will be at the top, and it will be like the controller of every other thing. Okay, so imagine when we want to create an algorithm, and for a particular something, probably a particular word or something, or we want to even do arithmetic. Like, okay, I'm just thinking deep, I'm thinking wide, trying to create a condition that if a particular condition is satisfied, then multiply the number of words inside this file by this and then give an output. So this is where the word count what the word count command comes handy. And word count command cannot actually perform action by itself unless we understand concept of redirection, input redirection, output redirection, and the likes. Let us do something else. Let's say I want to sort something. There's another command we have, sort. You can sort mm, okay. You can see we can we can sort lines of text. We can we can do this. There's a command called unique, that is to omit repeated lines in a particular text. We can use this man is very powerful. I'm even still trying to learn it. We can use it to print lines matching a particular pattern. This man, you can see word count, print new line word byte. Head is another function where it can use you can I'm going to send this document. This head is it outputs the first part of a file. This tail outputs the last part of a file. So now let's do something. Let's say we want to output the first two lines of the first two line of the content in a file. We are going to call it a day in the next 20 minutes because I know that we've used time. If I don't do like that, I can go on and forget time. But we need to moderate things. So to output the first two lines of the content in a file, imagine what we have here. New file, we have new file here, and we have I am just a regular file. How many line? One, two, three, just as it is here. What we want to do now is, peradventure we have more than like 20 lines. In fact, let me do that. Let me come to let me just look for dummy text. Okay, okay. So let me nano new file because I want to add multiple lines and I can just paste. Oh, sorry, I can't switch. Um, okay. So back to where we are. Terminal. My lord. They are all on single line. So, okay, we just have this and work with this. Okay. Okay. So how many line we have here? Word counts, lines, new file. We have 6 lines. So we want to print just the first 3 lines. And that is possible. The first 3 lines, not the last 3 lines. This is where the head command comes handy. So we can do manual, read the manual man head, and we'll see. We can see when we want to print the first number of lines, we use this flag dash n, and then we have to specify the number. Okay, okay. we can do add number first 3 lines for new file. I don't know if this will work. We have to feed it. Okay, I think that does not work. Excuse me. Okay, we have add number of, in fact, okay. So there is no special this thing. This is just how it will be. So what we are supposed to do is add number of lines for 3 lines for new file. Can you see when we cut the new file, the total, this is what we have. We might see this question like this, and we can now do something. We can redirect the output. Eh? We can redirect it into a separate file. So we can say add then the first 2 lines of new file, send it into new file 2. We can cut new file 2. You can see that the output is not on the screen, but it has been sent into new file 2. So this is the power of this operating system. It's so powerful because we can have a bunch of things to do, and we don't have the luxury of time to be doing them one by one. With just a simple command that are being added, concatenated, or piped together, we can do magic. We can do powerful things. Now there's this last one. Okay, we talked about input, standard input redirection, standard output redirection, and then there is the last one. There's the last one. It's called standard error. Okay, there's something I want to bring out. Okay, it's on my slide. Now, the ability of Linux operating system that allows us to change the standard input output. Okay, now there's what we call file decryptors. That is how files are being handled. We have standard inputs, which is 0. We have standard outputs, which is 1, and then we have standard error, which is 2. Now, these things are very, very important in order for us to understand. 0, the code is actually what we need to focus on. Let's just have this, like something like this exist. Probably when we are reading our document, our material very well, when we come across this, it becomes easier to understand. We just have this code, binary code, this code. We have 0, 1, 2 as file descriptor. 0 is for standard input, 1 is for standard output, and then 2 is for standard error. This works when we are working on the shell, and probably, for example, let me be specific about the standard error. We want to send in data. We want to display, okay, we run a command. There's a particular command we run, and we are even unsure about the command, but we want the command to still execute, notwithstanding if errors are going to be what displayed. So in that aspect, there is a way whereby we can redirect the errors the possible errors that might occur into a separate file. And imagine when I do something like, imagine I just want to cut a file that does not exist. I want to cut file. This is an error. And imagine I'm working with a very big with a very big file, or with big files, with large files or big data, and I need to do this command such that this command will run like ongoing. It will search through, it will traverse, it will search through every other directory there. Probably I run this command that should display every file with the txt extension inside probably the directory. Is a forward search this time around. Let's say there is a directory called desktop, you understand, from this place. So I'm trying to tell it to search through directory called desktop, every file that is what that has the file.txt. Or probably I want it to search through the desktop directory, and let me say there's another flag we can add, recursively at the same time search through the subdirectories for all the files that display all the files with the .txt extension. So something that will run and keep running till it get to the last. Okay. So we are unsure. Some things might not be present, some might be present. So we don't want it to actually flood the screen with all the error messages and all of that. We can redirect the error messages alone into a separate file, and it will give us like a log, and we can check them later on to see what is inside. Probably let me use another illustration. If you have installed some application before and you finish installing the application, you might see that they will tell you that you have the install log file. It will, you see something like log.txt. That is like a command like this, whereby every of the step in the process of installation are being redirected to that .txt log.txt file, and it is a command that handled that. Probably you are even doing installation and there are errors that has happened and the installation failed. You will see something like log.txt, or you see error.txt, and that is where you'll be able to check what particular line or what particular space or what particular side had error. So back to where we are, we have standard input with the code 0, standard output with the code 1, and then standard error with the code 2. In most cases, the way these things are being used is between the standard input output and the standard error. And this thing works in this way by using, you can see, you might have seen a code where they do something like 2 and 1. What does this mean? This is telling us that redirect 2 is for standard error. It is saying redirect the errors from this command, and even the output 1 is for standard output inside file. This is might not be clear. It's saying redirect error incoming. Let me, when we see something like 2 and 1, you can see something like 2, you can see something like happens like this. something like this. Most cases we don't put one because if or okay, you can see something like this. You can able to see something like this. So this one redirects errors and outputs. This one, it redirects errors alone, errors only to file. Redirects output to file. Redirects sorry. Okay. I think this is same thing as one above. Redirects out error, okay, output and error to file. So basically, so what the basic thing that is needed to understand is you understand that the code for standard input is 0, code for standard output is 1, code for standard error is 2. So sometimes when you use this, it is where when you see 2, you know that standard error or error from the command is what is being redirected. Now let's practicalize this to make sense. For example, let me say I I let me create a file. We have a file already, tags. We have tags, abi? Cat tags. This is the content inside tags. Now, look at something. I can say cat tags and another file, but I don't want it to display the output to the screen, but I want it to redirect it to file, to let me call it to my file. Instead of giving me the output from this and this, I want it to send it into my file. Now, this cat now, what it's going to do is going to display the output of this man, and at the same time display the output of this man. If normally we run it to this screen, let me run it first. You can see the first task here, we have the output. But look at the error. This is an error. It said cats file, no such file or directory is an error. So probably we want to run something like this, and it is going to be something repeated for so long. And um, we of course we know how many errors will be displaying on the screen like that. But instead, we want to keep the errors in a separate file and let the code continue to execute. That is where the standard error redirection comes in. So we can do cat tags file. Let me clear screen first. We can do cat tags and file, but this time we can instruct it that send both the input and send both the input and um, the error, send it into um, my file. Am I correct with this? Okay, excuse me. Okay, sorry. This is what I want to achieve actually. Cat tax file. So this is how it works. Because I was skeptical before. Send it into my file. So they are telling it to send both standard, the output and the error into my file. Okay. I think I'm missing it though. Excuse me. Okay. This is specification. The command, the standard error where we want it to be sent to, and then the output where we want it to be sent to. But actually, we can do the two at once. That is what I want to achieve. This is it here. Okay, the command, the file. Okay. So we set the command on the file and then redirect, just like it is here. So we can have at send both the standard error and standard output. Yes. Send it into my file. But this time around, it's going to, okay. Okay, guys, I think I have mixed it up with what I already learned. So I have mixed it up. Okay. Using the material before. Okay. Okay. Message. Okay. So, but I want to store it into a file. Okay, guys. Okay, I think I have to use a pipe. I have to use a pipe because it is now more than one. Okay, this is it here. I have to pipe it into, let's see, this is what I meant. If I say cat tax file does not exist. So send both the standard output and the error. Probably I don't even need to. Let's see. Hmm, okay. So I need to pipe it. Let me do that. Where we have cat tax, then we have file, which does not exist. Both the standard output and the standard error, pipe it into file. Oh, now every of my okay. I mixed it. Let me just save that for later. We'll solve this probably in the next class because there's a possibility of course. And okay. Okay, guys. Hello. Is
Yeah,
everyone still
I'm
there?
here. Yes, so
Yeah,
I
we're
apologize.
still.
I'm still here.
Uh, yes, for this last one, I think I have mixed it up because I couldn't get what I was looking for. Okay, probably let me just try something. Okay, come on.
Hello. Okay,
Yes, sir.
can we just do it tomorrow? It's almost 12.
Yes, 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 we can. All right, guys. Let's continue tomorrow. I think this session we've been able to learn a lot of things because we moved from this to that to that to
Mm-hmm.
that, and everything is actually they are all interwoven because they are all needed in order to become a, a super user. That's what they used to call it. To become a super user as being a Linux person. So we'll continue tomorrow, and at least we are so much ahead of the project, what is coming. With all of these fundamentals, everyone should be able to do well and
Mm-hmm.
be able to attempt all the tasks and even gain more understanding as we study the resources that will be given to us. So I believe
Okay.
this is something like this is achieved. So I'm happy with that, and thank you guys for staying around. Yes.
All
If
right.
we have anybody I want to say anything, yes.
Yeah. So, what are we expecting tomorrow, really, from the tasks and everything? Yeah. Any idea? Anyone with an idea?
Tomorrow, this is the intranet. Tomorrow, following the planning.
I think tomorrow is like a repetition of the things we've done. So,
Yes, this time around they'll be graded.
yeah.
They will be graded. So sorry, not here.
Okay, I want to quickly say it has been a great session. Thank you, Mr. Michael. My voice will start cracking because I'm tired. So
Sorry.
Alright.
I'll be signing off now.
Okay. So this is what
Okay,
we have
thank
tomorrow. It's all right. Thank you so much. We have the
Okay.
shell and all of this thing
Good night.
repetition.
Sorry.
Yes.
Yeah. Good night.
This is 12
you.
o'clock. All right.
Good night. Thank you.
All right.
Good night, everyone. Probably Abisola has gone to sleep. She
Okay.
has.
Yeah. Okay, good night.
Really? Wow.
Bye.
Uh,
Good night.
good night. Yeah.
Yeah, thank you so much, Mike. Have a good night.
Thank you so much. All right. Bye.
All right. Night, everyone. Thank you.